I feel like it's totally worth noting here and starting off this lesson with pointing out to you guys that after this video, you only have 7 more video lessons that you have to do in this class. So, yay, that's exciting, that's motivation. I'm going to start off by saying that. Hopefully, it'll put you in a good mood. All right, now think about the first 2 lessons that we've done in our quadratics unit. Those 2 lessons, we learned how to graph a parabola. The rest of the unit, so this lesson and the 7 more after it, are all about solving a quadratic. So what that means is something like this. So you've got an x squared, it's a quadratic, and you're asked to solve it, which means you want to figure out what x equals. So like, what can I plug in for x in this equation that actually makes this equal 0, the number on the other side? So that is what we're going to be doing the rest of the unit. But let's tie it into what we know so far. So a quadratic, remember, has the general form y equals ax squared plus bx plus c. We've seen that before. It's how we calculated the negative b over 2a. I feel like it's worth noting that, remember, they can also say f of x. So those are the same thing. Those are interchangeable. Now to graph it, what we did the last 2 lessons, remember that we found the axis of symmetry, and then we found the vertex. Then we made our table, and we plotted the points, and we had the picture of our graph. Okay, from this lesson on, like I said, no longer are we necessarily graphing, we're going to be solving. So something is going to change about the general form. The right-hand side stays the same, but the left-hand side, instead of it saying y equals, it's going to say 0 equals ax squared plus bx plus c. So when they remove the y and replace it with the 0, when you see a quadratic equaling 0, that means that we're solving the quadratic. I want to figure out what x equals that I can plug in where this is actually going to equal 0 on the other side. Okay, so kind of let that be your hint. If you see a 0 instead of a y, that means you're solving for x. Now, think about it. We replaced y with 0. So if you think about the graph of the parabola, where does y equal 0? Well, y equals 0 anywhere along the x-axis here. Any point on the x-axis has a y value of 0 in its ordered pair. So therefore, when we're solving a quadratic, we're just trying to find the x-intercepts. And if you don't remember what that means from first semester, x-intercepts just means where your graph crosses the x-axis. Because those are the points where the y value is 0. We replaced y with 0, so that's what we're kind of looking for. Now, there's actually 4 ways to solve a quadratic for x. So there's several methods. Oh, there's more than 4. There's a lot of ways, okay? And that's kind of why there's like 7 more lessons after this. There's a lot of ways to solve a quadratic. This is just one of them. We're using graphing as our method today. There's 4, though, terms that they can use that are going to clue you into they want you to solve it. Obviously, if you see it equaling 0, that means solve, and there's not a y there. But there are synonyms for solving. So synonyms means it means the same thing. All the terms mean the same thing. They could say it real clearly, and they could say, find the solutions of the quadratic. They could also say what this one says here, solve the quadratic. That's pretty straightforward. Solutions is pretty straightforward. The next 3 terms are not as straightforward. They could tell you find the x-intercepts. That means where does it cross the x-axis? Where does it equal 0? The y value. Okay, they could also say find the zeros. And that term comes from the fact that we replaced y with 0, so they kind of just call the solutions zeros. The last term is roots, and that will make sense after we do the next lesson. Okay, this top part is kind of like a lot of general information we'll need moving forward. We'll reiterate it every lesson, so it will eventually sink in, but get those terms down in your notes. These are important to point out right now from the beginning. Okay, so let's practice. Now, I see a 0 instead of y, so that's my clue that I'm trying to solve. They also asked me to solve. So, like I said, graphing is one of the methods that we can use to figure out what x equals here that's actually going to make this y value equal 0. So what you're going to do to use the graphing method is exactly what we learned in the last 2 lessons. So you're going to start off by saying, all right, a is 1, b is -6, c is 8. Kind of don't pay attention to the 0 on the other side. Remember when we graphed, we first found the axis of symmetry. This is 100% review right here. So the opposite of b would be +6 over 2 times a. That would just be 6 divided by 2, which is 3. So the axis of symmetry is the line x equals 3, which would be right here. And then remember we found the vertex. Here's what I'm going to do. I know I put the vertex in the middle of my table, and I know that with this number I have the x value of the vertex. I just have to find the y value, so let me plug in 3 for x, and I get -1. It's kind of hard to see. That's better. Okay, so I want to get a good picture around the vertex. So I'm going to pick 2 numbers smaller and 2 numbers bigger to also plug in. So let me plug in 1 here. This is 3. Cheat off yourself if you're confident. I'm pretty confident in my skills. I would hope so. I know that 2 steps away from the vertex, those should be the same in either direction because of the symmetry. So I know that when I plug in 5, I'm also going to get 3. If I plug in 2, I get 0, and I know that 4 would be the same thing. Okay, let me kind of show you. I did that. All right, so let's go ahead and plot these points, and hopefully it's a nice U shape. So the vertex was at 3, -1, 2, 0, 4, 0. There we go. Okay, none of that is new. There's only one small part of this that's actually new, and it's taking it one step further and saying the answers. So let's think about it. After graphing, and remember what I said up here, they replaced y with 0, y equals 0 along the x-axis, so I'm looking where my u crosses the x-axis. Well, this u right here, it crosses the x-axis twice. That tells me that there's 2 solutions. So where does it cross? Well, here it crosses right there and right there. Those are the answers. So let's see, that's when x is 2 and when x is 4. If you were to look at the table that we made, look at the y values that correspond with these solutions. So 2 and 4. Okay, so I plugged in 2 right here, and I plugged in 4 right here. I can see really clearly from my table that 2 and 4 are the answers. Because if I notice, the y values that correspond with 2 and 4 were both equal to 0. And guys, that's exactly what I'm looking for. This quadratic right here didn't equal y, it equaled 0. We plugged in 0 where y used to sit, so I'm looking for the x values that have a y value that's 0. The table made it clear. If the table didn't make it clear, you just look for the x-intercepts. So that is all you're doing with this stuff. I want you guys to try number 1. Graph it like normal. Look at where it crosses the x-axis. I will tell you, and that's why these questions are below the graph, there are some different types of scenarios that you might see. So let me do example 2, and I'll show you what I mean. But I start the same way, so A is 1, B is 2, C is 3. Find the axis of symmetry. So it's x equals, let's see, the opposite of B over 2 times A. So that'd be -2 divided by +2, which would be -1. And I'm going fast through these steps because we've done this several times now. If you don't have it down, you gotta practice or ask for help. Okay, now I'm going to get the vertex on, so I know the x value of the vertex is -1. I'm just going to plug that in to see what the y value is. So I get 2. And then let's do 2 numbers smaller, 2 numbers bigger. I'm pretty confident with my abilities here, so I know if this one's 3, 0 has to be 3. And then when I plug in -3, I get 6, so this guy's 6. Okay, so let's go ahead and graph my u here. There's the vertex, 0, 3. Cool. Okay, special case going on here. I told you on the front, since the y now is equaling 0, I'm looking for all the places when y is 0, which is along the x-axis. Okay, I don't know about you, but from what I notice, my parabola does not touch the x-axis. So what does that tell me? That tells me that there are no solutions. There's nothing that I can plug in for x here that actually equals 0. And that's a possibility, okay? You might have no solutions here. So that's exactly what I'm going to say. No solution. Very sad. Or maybe that's easier. I don't know. So number 1 might be kind of a special situation as well. So you want to make sure to try that so you are aware of the other possibility for your answer. All right, the reason there's more than one method for solving is because graphing sucks, if I'm being totally honest. Graphing is actually a terrible method to use for solving a quadratic for x. Has tons of disadvantages. Let me show you with this last example here. Okay, it's kind of getting super redundant, but if I were to graph this quadratic, let me just do what we've been doing. Axis of symmetry would be x equals opposite of b over 2a. So that'd be -8 over -4, which is 2. There's my axis of symmetry. If I made my table, put my vertex in the middle. Okay, so that's 3. Let me go with 1 and 0, 3 and 4. Okay, so that'd be 1 and 1. When I plug in 0, I should get -5. Let's make sure. Yep. Okay, super fast, but let me get these points on here and show you why graphing just is not the best method. 0, 5, 1, 1, 2, 3, 3, 1, and 4, -5. Okay, so there's my upside down u. Now, I can see on here, and I'm again looking at where my u crosses the x-axis. So there are solutions this time. I can see pretty clearly that there's 2 because I see that my u crosses the x-axis right here and it crosses right here. But here's the problem. I can't see where y equals 0 on my table because I passed right over that. And I can't tell because it's crossing in the middle. So it's going to be a decimal answer for both of these. And unless you have like crazy vision, there's no possible way that you can look at this graph and tell me what the answers are. So I just can't say. So graphing, the biggest disadvantage of graphing is that if your answer is a decimal fraction, you can never tell me what the solution is if you use graphing to solve it. Okay, so again, let's fill in the bottom. Kind of reiterates what I just said. There's 2 major disadvantages I'll point out right now. The first one is that it's time consuming. That's kind of a lot of work to find the axis of symmetry, make a table, plot the points, look at where it crosses the x-axis. That's kind of a lot of work, and some of the other methods are not as much as that. So first disadvantage. Second most important disadvantage, you're not able to find the solutions in some of the problems if the parabola doesn't cross at nice points. Or like I said, if the answer is a decimal, you will never be able to say that from using graphing. Okay, so that's why we need more methods. Yay, stand by for the next method, next lesson.